Hey guys, I want to help you out with your mid-chapter test. I want to show you one thing that's going to help you. Number one, you're going to just see a graph, right? And I'm just going to mark this off. 1, 2, 3. 1, 2, 3, and it's going to go way down there. 1, 2, 3, 4, 5, 6, and the graph goes down just a little bit farther. Just right about there. But it's a happy graph, you know. And it does cross through this point here. And I'm going to point that out. So that's y-intercept of, what's that, -6. And that's kind of an important number, right? Parabolas, remember, they're in the form of ax squared plus bx plus c equals 0, right? That's our function right there. And this y-intercept -6, that equals c, right? That tells us where it crosses the y-axis. So when you look at a list, you're going to be given a list of some equations. You're going to say, you know, x squared minus 6 equals 0. X squared minus x minus 6 equals 0, and x squared plus x minus 6 equals 0, x squared plus 5x plus 6 equals 0. Right, so you're going to be given a laundry list, A, B, C, or D, right? And what I want you to do when you're looking at this is if you're very good at factoring, I want you to look at these. So these are our zeros, right? So we have a 0 at -3, and we have a 0 at +2. Right, those are our roots. That's what we talked about before. These are our roots. It's not so difficult. It's not so horrible. If we wanted to, we could just plug these in and plug it in for x. Plug in -3. -3 squared minus 6. Does it equal 0? No. 9 minus 6 does not equal 0. Right? Let's put in -3 here. -3 squared is +9. So +9. -3. So minus a -3. So minus a -3, which is +3 minus 6. Does that equal 0? No, that's 12 minus 6. That equals 6. So get rid of that. That's garbage. We don't even like that. Boo. Spray paint all over you. Boo. Okay, so we'll go to the next one. All right, and we'll put in -3. So -3 squared, that's 9 again. Plus -3. So plus -3 minus 6. Ah, look at that. -3. -6 is -9, 9 and -9, that equals 0. So this is my guy right here. I would choose that one right there. Just in case, you can try the -3 here. It's 9 minus 15. Ooh, plus 6 equals 9 minus 15 plus 6 equals 0. Okay, well that works, right? So 9 plus 6 is 15, minus 15 equals 0. But then, hey, let's go over here, +2. +2 equals 4. 2 squared is 4. plus 5 times 2 is 10. So 4 plus 10 is 14 plus 6 is 20. That doesn't equal 0. So the last one doesn't work either. So that doesn't work, that doesn't work, and that doesn't work. That's the only one that they both work for. All right? So, going to move on. I'm going to try something else. Bye-bye. And so the cool thing about this is by the zero product property, if it says by the zero product property, comma, if, and I'm going to put something in here that's a different idea, 3x minus 2 times x plus 3 equals 0, then dot, 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 right? And all that means is, hey, then we have two roots, right? And all that means is, all right, solve each piece for 0. 3x minus 2 equals 0, and x plus 3 equals 0, right? And what you're going to do is when you're finished, you're going to say x is equal to one thing and x is equal to another thing. So let's start with this one. We're going to add 2 to both sides. And that goes away, and that is 2, so 3x equals 2. We're going to then go ahead and divide both sides by 3. And 3, and that cancels out, becomes a 1. And x equals 2/3. So there's one of my answers, right? One of my real zeros. And then go back to this guy, and we'll just subtract 3 from both sides. And x is equal to -3. I mean, we're finished with this one. So we have our two things. That's what you're going to put on the line, right? Big deal. The numbers aren't the same, but hey, you know, it's what it is. All right, and then there's we'll move on to the next type of problem. This is funny. Yeah. You'll like this kind of problem. It says, write a quadratic equation with these guys as roots. All right, so write an equation ax squared plus bx plus c equals 0 with the following roots. All right, sorry about my crazy writing. I just want to get this done. So it says we have a root that is, we'll say a root of, let's go ahead and say 2/3, and a root that is -6, right? And so what you do is what we just did, only backward, right? You know how we solved x equals something, right? So we're going to say x is 2/3, and x is -6. And what I want is to get this alone and not have a fraction. So there are two things that are going to happen. The first one is I'm going to get rid of this fraction. I need to get rid of the fraction. So here we go. I want to get rid of this denominator, so I'm going to multiply both sides by 3. And that's going to be 3x equals 2. All right, well, we're real close. I want this to be 0, so I want to get rid of everything on this side. So I'm going to subtract 2 and then subtract 2. And I can't really put 3x and negative 2 together. I have to write them as a binomial. So it's 3x minus 2 equals 0. And of course, if we had done this backward, you know, you would have seen. I would have added the 2, and we've been at 3x equals 2, and then I would have divided by 3, and then x equals 2/3, and that's how we got there. So we just did this in reverse. Well, this one in reverse is, oh my God, super simple, right? Watch this one. All I have to do is get rid of this. Well, that cancels and gives me the 0 that I want. X plus 6. I am done. Okay? And so I want these two values written out for me on that test. And now you've taken care of 3 problems. All right? So let's move on. See how easy this is so far? We got about 5 more things to do. Right? And get rid of that, get rid of that, get rid of that. Okay, so let's talk about this guy. Oh, geez. This is so super simple, so super simple. This is just addition, sort of like addition of complex numbers, right? And so we're given a value, okay? We're given a value 4 minus 5j, right? And that's a number of joules in terms of electricity. And so we're talking about a series. And then we want to add to it, let's add to it 3 plus, I don't know, 3J, or 3 joules. Not joules, J-U-U-L-S, but joules, J-U-E-L-E-S. And that's a term in physics. We talk about electricity or power or energy in terms of joules. Energy is joules. Okay, and all we're going to do is add our whole numbers. So 4 plus 3 is 7. And then negative 5j plus positive 3j gives me negative 2j. Isn't that easy? Okay, so that's another problem. And we're going to get rid of that. Bye-bye. The next problem is simple. It says solve the following. And really, it's just factoring. So 1, 2, 3, 4 factoring problems. Right? And I'm going to make them relatively simple. I may take out one of the factoring problems and put in something different, but I may not. So here's the first factoring problem. It says x squared minus, I don't know, 6x minus 16, okay, equals 0. And what you're going to do is you're going to look at this and remember first step is, remember your first step? Put your googly eyes on that symbol right there, right? Boop, 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 boop. That's negative, so hey, I know I'm going to create two things, right? And when I solve this, I'm going to solve all the way down to the x equals something, okay? And I know x times x is x squared, so I know that part. I had already looked at this, and I said it's negative, so it's got to be one of each. That's cool. Factors of 16 whose difference is 6. Well, it can't be 16 and 1. Certainly can't be 4 times 4, because 4 times 4, their difference is 0. So to me, it's got to be 8 times 2, and the 8 needs to be next to the negative. So the 8 is here next to the negative, and the 2 is here. And if we FOILed this out, that's exactly what we get. Good stuff. Now solve x plus 2 equals 0, and x minus 8 equals 0. I don't have a whole lot of time, so I'm just going to do the math real fast. That goes away. X equals 8, and minus 2 go away. Negative 2. X equals negative 2. All right, so you can either write it x equals negative 2, x equals 8, or negative 2, 8. And put them in as a pair like that. Okay, that's good. There are 4 of those. 1, 2, 3, 4. Super simple. All right, why do I put 4 factoring problems on one test, on one half of the chapter test? Here's why. That is the single most important skill you need to pull from this chapter. Okay? If you don't know anything else other than factoring, when you finish with Algebra 2, I'm almost okay with that. You should know a couple other things because it's really going to help you out in pre-calc. But if you don't know them, that's the way it goes. All right. So here's the second to last problem. It is determine whether this function has a maximum or a minimum. I'm going to say, I don't like that. I'm going to say 1/3. No. Let's say let's just say x squared plus, let's make it a nice easy one, plus 2x minus 3 equals 0. Okay, so that would be, the question is, max or min, does it have a maximum or a minimum? Does it have a max or a min? Well, look at this sign up here. If it's positive, it has a minimum. If it's negative, it has a maximum. Remember, positive, smiley face, points upward, it has a minimum. Right? So positive, min. Negative, oh God, that was horrible. Negative, oh, jeez. There we go. Okay. Negative, it has a max. Okay? So remember, negative max, positive min, smiley face, frowny face. Frowny face has a max, smiley face has a min. Anyway, so you would say it has a min. This has a minimum. And then you would do some legwork. Remember to find a vertex. We have to find axis of symmetry, which is negative b over 2a. Right? And so when we have negative b over 2a, Negative b is negative 2 over 2. So my axis of symmetry is negative 1. And then all I would do is put in a negative 1 here. So 1 minus 2 minus 3, it would be negative 4, right? Negative 5 plus 1 is negative 4. Got it? Sound good? All right. And last but certainly not least, let me just get rid of this. Last problem, we want to simplify a complex number. And what I want to do is 3 minus 4i over 5i. Right? And like I learned before the hard way, I don't want to make it equal to anything yet. I'm going to multiply by I to get an I over I. Because if I multiply my fraction by 1, I haven't changed my fraction. So I over I, square root of negative 1 over square root of negative 1 is just equal to 1. So if I multiply both pieces by this, both the numerator and the denominator by this I haven't changed anything. But the problem is this. I have to distribute. So 3 times I is 3i. Minus 4i times I is 4i squared, which in turn is going to equal 3i. Negative 4 times negative 1, because I squared is negative 1, equals 3i plus 4. We would actually switch these around. So I'll show you when we're finished. Dun, 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 dun. And then 5i squared, because we've just multiplied 5i times I squared, is negative 5. Okay? That's 5 times negative 1, because I squared is negative 1, equals negative 5. All right? We do not put the I term first. We put our whole term first, then 3i, and all over negative 5. If you don't write it this way, I'm not going to cry. I want you to remember that this is how it's supposed to look. Other than that, everything else is factoring. Okay? One of them is going to be a complex number. The other one is not going to be a complex number. Let me show you what that complex number is going to look like. I know you're afraid of this, so I don't want you to be worried about the complex number. Get rid of that. This is what I mean by a complex number. If I do x squared minus or plus, let's say 15, right, equals 0. And I want to solve this for x, I'm going to subtract 15 from both sides, right? And I'm going to get to x squared equals negative 15. Then I'm going to come over here and I'm going to hit this button and I'm going to take the square root of both sides. Right? So x is going to be equal to plus or minus square root of negative 15, which I'll break up into negative 1 and negative 15. And I'm going to say plus or minus I times the square root of 15, right? Because I broke this up into the square root of negative 1 times the square root of 15. Can't break 15 down anymore. There are no perfect squares in there. That's what this is going to look like. Okay? That's probably, in my humble estimation, the most difficult problem to solve. All right? And I may or may not put that on there, but it's there, so I may just leave it. Right? follow that format. Other than that, we are good to go. Right? Any questions? Always, always, always ask away on Google Classroom.